Hi, hello, welcome to VHDL Basics. Today we are going to see about your tick define and if-def statements in verilog HDL. For that, I am taking an example of synchronous and asynchronous reset. So, what is meant by synchronous reset? So, the reset will have an impact whenever the clock is available. That is called a synchronous reset. Asynchronous reset in the sense independent of the clock, the reset will have an impact in the our circuit actually. So coming to the tick def actually. So tick def we are using the tick def for defining the macro as well as the defining the word actually. Here I am defining synchronous reset as a word actually. So if I in the line number 6, right, I will check that if def synchronous reset is present or not. If that synchronous reset is defined, then this circuit will work as a synchronous reset circuit actually. So line number 7 indicates always at pause edge of clock. So in the sensitive list, I am adding only the clock. So whenever the clock is changing, the always block will work actually. So the reset um, will not have direct impact of the output. So the reset will depends on the clock passage here actually. So the else part we will come to later. So I have simulated this synchronous reset. So I will explain that waveform actually. If you see, the reset is one actually before the rising edge of the clock, but that doesn't make any impact on the output Q. But the rising edge of the clock, right? At that time, the output Q becomes zero. So this is how the synchronous reset will work actually. If you check the next rising edge, right? At that time, the reset is low and D is high actually. So the D value will be reflected in the Q actually. The third racing edge at the time the reset is high, so the output Q is 0. Now I am going to comment out that tick define sync reset. So the condition we are checking in the line number 6 will fail. So it will go to else statement. In the else statement in the sensitive list I am having passage of reset. So then it will this circuit will work as a synchronous reset. So whenever the reset is going high, right? So it will have an impact immediately independent of the clock actually. So I have simulated this particular condition. So I will explain that in this simulation waveform. So if you see the reset is high before the rising edge of the clock, then if you see the output Q already is 0. So independent of the clock, the output Q is reflected. The next rising edge, right? At that time the reset is low. So the D in value will be reflected in the Q. But in the case of the before the next rising edge, right, the reset is going high. So that will make an impact in the output immediately. So you can see the Q value the going low before the rising edge of the clock actually. So this is how asynchronous reset will work. Thank you for watching this video. Mm, Please like, share and subscribe this channel.